All right, so there is recording occurring, so he is aware.
I know it has a lot of features and stuff, but so we're just gonna get rid of it.
I think that's the thing, yeah.
Just like that. I grabbed this pretty definitely about Python, and it starts off and it's like, hey, I've seen guys go like that. I'm 16 years old, I've probably just 90 courses. And he has his 5 stars on here. 20,000 people.
All right, check the Slack. You should have the link to the YouTube video stream thing. Yes, please mute your computer, by the way, unless you want to have the headphones to listen to me, but it'll be a little weird still, but you can use your headphones if you want to hear me itself, because I am recording audio for the recording, but if your speakers on your computer on, we will hear ourselves in a delay. So be aware that you will hear a delay if you do the headphones. So I don't recommend headphones.
There's feedback or everything else. It's very
That too? Okay, then everybody turn off your speakers so we don't get any feedback. Make sure your computers are on mute.
You didn't like the Zoom video?
Oh, what?
Zoom?
you recorded on him.
What'd I do? I don't like something. What?
No, I just remember Jason, like, one day I stayed home and sent me a Zoom request and I used the Zoom video. Yeah. Yeah, it was cool.
I don't know what's going on. I have no idea what you're talking about.
It's like a meeting platform. It's a lot like Hangouts. It's Zoom, I think.
Yeah,
They went public.
Did they go?
Where is this code?
Slack United.
So what happened to the
United chat. Slack. 56 United.
So
It's fun, isn't
Where
it?
is this?
I don't enjoy it.
Is that the same?
Yeah, binary.c is United. So just go look at United again. Those recent binary tree.c. So scroll up.
We go there.
A little bit.
Because I'm stressed out.
That is binary. Yeah, that's it. So download that. You'll have my exact code.
Good.
What's up? Hang on.
Nothing, we were calling Joe a stress ball.
Folder.
You're being recorded.
Then you can get it back that way.
Oh, this is music being recorded, so you can break the words later.
That was Christian.
No, I would never say it.
All the evidence is being captured right now.
No,
so
it goes
it's all
to
good.
people experience. That's what they're calling it.
What?
They call it in our company. It's people experience.
Yeah.
Yeah. We don't have an HR department. We have people experience.
Wow.
HR has started getting a bad name from all the Me Too stuff that's been getting around. HR not doing anything about it. So the word HR is getting a really bad name.
Yeah.
You had it before that, so it's okay.
Yeah.
Play around with something. Oh my bad. Just making it.
It's all about improving the employee experience. Alright, everybody in? Everybody can see? Right? Anyone see? Everyone good? So do remember on YouTube you can make the screen full screen if you're having trouble seeing the code. So do take advantage of the full screen feature if you need to. But otherwise, let's get into it.
Anything on the left, so you can make it a little bit bigger.
What's that? Yeah, I can do that.
Oh, chat.
No, the directories.
Also, make sure you do the quality at its higher quality. You leave it to at I think it might default 480. If you can improve it.
No, default 1080.
Mine defaulted to 3.
Some do, some don't. So I was gonna check. I want to make sure people are aware that they can increase the quality if it didn't auto do it right. So if your computer didn't auto set to nice high quality, you can set it to that. So I'm gonna kill that one. See that here.
That looks.
We are do stream at full 1080. At least I think I do stream at 720. I know that. I do stream at full 720. Why are you not charging?
Yeah. But only the first instructions sent from its function.
Who's charging? It's no light. Okay. All right. Just so you guys are aware over here, just so you guys are heads up, there is a there is recording for so you know you are your voice may be captured. I'd like to be aware of that. I don't want people to be like, wait, how would be recorded? I'm against this. So if you want to
I can't just say like, no, that bad
Oh,
picture over there.
So if you do want to talk a little more, we do have that room right there that you could go into if you want. So if you want a nice larger conversation, you can do that. Meetings.
Is there a recording right now?
Yeah, I'm recording.
So when I said this is not
What's that? So yes, you're coughing, stuff being captured right now. I might cut out the beginning part of the stream from the full recording, but just letting everyone know.
So I heard you say there's snacks.
Probably. Very possible. Yeah, if you're gonna have if you want to have the ability to talk a little louder, then again, you have that room right there that you can use for your purposes. Ooh, I'm gonna do something quick before I finally get started. Which one? This one?
No, look.
That's well, he's looking at you.
Because he knows he's a troublemaker too.
What? Let's switch over to that one.
This is really
All of them.
it's politically incorrect stuff.
Dang it. 1 second.
Some of the times you can't hear it.
Do more setting configurations.
No.
Let's get to it. So here's our binary tree function that we've been working on before. So we have the binary tree node, we have the add node for it, we got our root node for node. We have all our stuff here. Display tree on enter, display tree on departure, does contain our free node, our free tree, populate tree, our test cases, and our main function still. So you can, of course, continue working with your code and just modify it or create new functions. You can, of course, download the binary challenge from the Slack system if you want to use that. And have a fresh start so that you have this exact same code if you want. Otherwise, we will just go forward. So, first things first, I want to go ahead and add in from the first challenge we did on yesterday, which was to actually create our new node. So, following the idea that our structs over here, we'll create the struct up here. So type def struct, and this is the one I go with, Q node. Just the letter Q and the word Q sound the same, so I might as well take advantage of that. Make a nice short item for myself. Oh boy, the snack bags are going to be a fun thing. We'll see how that goes. So, we did say that in our queues, our nodes are going to store at least, it is a binary tree. So again, we can use this pointer file that we had from last time that has this linked list node right here to give us an idea. We know this is going to be different. We're not storing integers in our system, but we do know that this is going to be the same pretty much. So we can reuse that. Let's go ahead and do that. We'll do struct qnode, because as of this line right here, the type def hasn't triggered yet. So we can't use qnode by itself. We have to use the word struct. There it goes. Now it's purple. Before we can actually use qnode, because type def hasn't triggered yet. So type qnode star next. Let's do that. Make sure it's right. Now, as for the value of this one, we're not going to be storing an integer value. We want to store what exactly? Does anyone remember? Yeah, a pointer to a binary tree node, which is what these are right here, based on our comment. A node for the binary tree. So that's what this is. Now here, I can use the word node because by this line 15, the type def for this one has triggered. So inside of this one, it hasn't, but outside, once I hit line 12, type def node has triggered, and now I no longer have to use the word struct anymore. So I can do node star for this one, node star, and I could use, again, value, just to follow that canonicalness. But what I actually liked in this one was that I'm going to use the word node. Small node and capital and large node is different. Remember, those are two different identifiers, because capital letters and small letters are not looked at the same. If you wanted to, you could also go with binode, just because it's part of the binary tree. It's a node of a binary tree, so that'll kind of follow a similar syntax of our Q node. But we'll keep it simple this time. We'll just go with node. Node, node. Sound good? You could also call it address, whatever you want to call it. This again, there are certain common names, like value or data, but there are also, again, the idea of using, just because it's canonical doesn't mean it's the only one that's the best. Doesn't mean it's the best to use. You can come up with a better name, use it. Your idea is for clean code. Code that is self-explanatory. That doesn't need a comment in order to use it. All right, it's behind it. Let's do that. Okay. And now, we of course need our root item. So based on the vote, we have head node. Yes?
Do we need node after that struct?
Not necessarily.
No.
It does have to be after the type def Q node. I just kept them in order of their type defs.
Yeah, there.
We created node first, we created Q node next, so I decided to keep them the same. They don't have to be. Q node could come before because as long as they've been defined, I can use them at any point.
You mean at the end? At the end, in the other, in the type def struct.
Oh, right here. Yes, we do need it here.
That's what I was asking.
Gotcha, gotcha. Yes, we do need that. And I'm going to actually show you an error specifically if I don't do that in a bit.
Oh,
So,
okay, that's fine.
yeah. I did an error this morning that's actually really helpful to see that type of error and fix it. So I am going to remove that later on, but we'll go for this for the moment. So we have this. We have our Q node. We have a Q node now. So now we got to figure out, though. I now want to add a push and pop function for this Q node system. But all this code here is for the binary tree. And then I have my main at the bottom. I do like that main's at the bottom, but I also don't need it to be there. And I do need to make sure that I keep in mind that we aren't declaring any of our functions in this program right now. So order of functions do make a difference. one of the students here did actually have the idea, actually now two of them I found out, decided to do the push node, the push function inside of add node in order to be able to test it. Good idea. Definitely a good idea. But in order to do that, if I wanted to do that and I'm not declaring, I need to make sure that that function is above add node. Otherwise, it can't be used, right? If I put push below add node, I can't use it in add node. So always be aware of that. If you want to use a function that is not above a function, you have to declare first and then define later. But in this entire function, we haven't done any of that. So we have a couple options. We could start functionalizing all our code, which canonically would go here. Now, sometimes the canonicalness may actually have a reason. Is there can you think of a reason why it belongs there? Or could I put them at the top like we've done before? We've used to put them up here. Could I put them here, or or is it better to put them here? Anybody else? We could put them here, according to, I think it was Xavier, I think I heard. Anyone else agree, disagree?
We do this with functions?
So I could declare functions up here, like we have our add node. So I could do void add node here, and then do the int. I'm saying I also would canonically do it down here, right? Lag. Give it a second. So, right, I forget about that. There is a lag. That's gonna make this very, very weird. Didn't think of that. I'd have been better to go Hangouts for this still. Have some of you guys just watch each other's screens, because at least Hangouts has no lag. We'll see though. He still has lag too. We're all using Yahoo. Everyone has a lag. So that's just a YouTube thing. So everybody can see it now. So we have our add node up here. We have our add node down here where I say 24. So 24, line 24 has the add node, or right below it has the, where canonically we put the function definitions, we put the declarations after type defs, or we put them before the type defs at the top where we've done before we even knew what type defs were. Is there a reason we would do the declarations after the type defs? Can we think of any?
You haven't defined the node structure yet.
Well, why would I need to care about if I have defined it or not? Does that matter for my declarations? Not quite. What was that? You're on the right path. I'm trying to get the right wording out of it. So think about pop. What data type is that going to return? A node star, right? So if I do that up here on line 5 instead of the void node, if I do node star pop, is that going to be a problem? Because node doesn't exist yet, right? So do be aware, that's why we canonically add them after the type defs, because our functions may want to use them. Our declarations may want to use them. We may send a type def into our function, we may return a type def. If you don't, you can definitely put them above the type def. Any functions that don't use a type def system can be declared above them.
Oh yeah, it's so slow, it's still going. Yeah.
Jesus Christ.
You need a semicolon after it.
Thank you.
I was like, wow, he's standing right there, it's still going.
I'm an amazing typer. Look at me go. I'll do something quick here, actually.
So Iron Man has that.
What?
Let me do something.
Like a little wrist to have a keyboard on it.
There is one called, what's it called? I don't remember what it's called. It's a tap one that actually is a glove around the fingers and you just tap out the letters.
Oh, the Nintendo Power?
No, it's just, it sits on your knuckles. It's not a glove.
That's cool.
It's like, I think it's called the tap keyboard.
Somebody's hacked, somebody's hacked.
How do you feel about those, the laser ones, the laser projector ones?
The what?
Laser
Oh, the laser
projector
projector?
keyboard.
No, I don't really get a good physical feedback that I actually hit a certain key. So the laser is on a grid that I'm not looking at, so I can't feel a physical key. At least the tap, it's based on the fingers themselves, so I put 2 fingers down, I know that those 2 fingers were triggered.
Oh yeah.
Clicky.
Especially in the Luther Springs on that keyboard.
You like my? You heard my clicky keyboard before. I need my mechanicals. I'm a blind typer. I need a blind typer. I need to know that I hit the key without needing to see the key. And a laser projected one can't do that. My hand slightly glide to the right a little bit. I'm hitting the wrong buttons.
Yeah, but to play that on that keyboard.
Well, yes, the physical, but if I start to trail, I'll at least feel the edge of a key and know that I'm kind of my hands are shifting. I won't know that I'm shifting until I hit a wrong key, and all of a sudden I'll see and be like, wait, what's going on? I also like the little physical feedback on the F and J keys to let me know that I'm on the home row. Yep. Oh yeah, no, I agree. The arguments are good. I get them. They make sense. Close some stuff down because I feel like this thing is chugging right now. What's that? Because the type def hasn't triggered by that line. So line 9, 10, for node, the type def hasn't triggered. The struct is right now evaluated. So we still have to use the keyword struct. Type def just allows us to not need the word struct anymore.
And then when you say it's struck, it triggers in the profile.
Yep. That's why we don't need to use it outside of that.
But I watched a lot of tutorials and then people they like define, but they usually don't have arrays and stuff like that.
Yeah, you will be using an array too. In your speller, you're going to use an array in some way, shape, or form. Either an array of pointers or a try, which is an array. But, all right, I'm going to use Hangouts as well. So if a couple students want to join Hangouts, they can. And then people can watch in so that you don't get the delay. So same channel, 56BE from Hangouts. Again, please mute yourself. You can still stay on YouTube if you want. I'm still streaming to it just so we get the recording. But since the delay is kind of confusing you guys, Hangouts doesn't have a delay.
5, 6,
560E. It should be green and say there's a call going on. So if you want, I do know that Hangouts has a limited number of people that can join. So someone next to you joins, you can just watch their screen. It's not going to work. You want to share a screen. But if you join the call, make sure you turn off your camera and you turn off your microphone. In Hangouts. So you don't have to delay on it. It's the same Hangouts we did yesterday. So you get channel 5BDE. 56.
Evening?
Yeah.
Oh, I don't have access to
Make sure you're logged into your CareerDevs account.
Yeah, I just have to find the right line.
The channel is 5_6_B_E. Let me make sure I can add other people. So, Melissa, you should see an invite for it. Anyone else not see the channel?
I'm in hangouts.com.
Yep, that's where you want to be.
Alright, now
I'm not there.
Do you see it yet?
all I see is Janelle's face that I joined the call with.
Melissa, you should see it. Who wasn't here yesterday? Right, so Xavier doesn't have it, Christian doesn't have it, probably.
But I think I'm in the call already.
Christian's on.
You are? You're in it?
Christian, I think. Yeah.
If you're next to someone, please check and see if they are good.
How do I do this?
Again, you can share a screen too. Just on my face, you mute it yourself.
But we're on YouTube. I went to 11K yesterday.
On my face, that was on
I used to. I used to have like.
I have, but it's really
I used to have.
on my face, they just
take it like that.
What do you mean sign in?
No, you buy whatever you want. You can buy
You can trade your way up too. I turned 700 into like.
I don't
8,000.
remember my password, so signing isn't possible, but I'm here.
Watch for the screen then.
Like, sorry, it's
Do you go to
Excerpt
go to
fee is
Hangouts, hit the
$3.
sign up button, it'll probably recognize if you're already logged in.
Download is 15
Go to
cents.
Hangouts, click the
I
button,
have
probably auto
40
send.
cents.
Yeah.
Talk to Arnell about resetting it later.
Calling
But
it
now
shares.
watch on someone else's screen. Watch along with them. Keep watching
Sure.
YouTube
Oh,
channel,
you
but
gotta turn off your.
the real doing this is
click
we
on
don't have to deal with the delay. Because YouTube has a delay.
Freaking
In the office.
Oh, okay.
Yeah. Before you leave today, check with Arnell, get him to reset your password.
4, 5.
Good quality picture, when did you take it, Cliff?
Oh, that could have been during cohort 2, I
I
believe.
used to have IOTA.
Oh, that's gonna be.
Now it's 60 cents.
Actually, one year has that money bill.
And it was
Oh,
$1.
yeah.
It's a 5.
One of our students that is now working any money actually did professional photos.
I can do that. Actually,
Who's that?
I can do
I don't know.
No.
Well, the first one's hired, that went to the QA team. He was hired alongside Nafisa.
Who would you buy?
Yeah. He used to do photos.
So we're just going to use Hangouts instead of YouTube.
Yvonne was a photographer for the longest time, so
I wanna do-
so he took that photo.
You wanted to talk to Arnell at one point. Did you ever do that? That was like 2 or 3 weeks ago.
Yeah.
Sure did.
He gave me a PowerPoint for Dave Rose.
All right.
Oh, really?
Can everyone see my screen now?
Yes.
Good. So this one should not have a delay. So yeah, we now have our keynote. We have that. We now canonically know we want to do our function declarations on line 23. So let's go ahead and add the correct declaration now. Node star pop. We also, and our pop is going to do return the node star, but not take any parameters. And then we want to do a void function push that takes what? Not an int. Right. Again, a node star. Again, we don't need the actual variable, the identifier now, because we're going to do that during the definition later on. So again, this is why we want to put our declarations for functions below our type defs normally, because we might need to use those type defs in the declarations. If you're not using the type defs, you can put them above, but then usually it's a little weird to have some above, some below. So usually you want to have a section in your file that's going to have all your definitions, or declarations, sorry. But this now, we can actually put our code wherever we want. And so I'm actually going to put these below the mains. That way, above main, it's our binary tree stuff. Below main is our queue stuff. Let's go all the way down to the bottom of the code. Go ahead and do, we'll do our first one, we'll do push first. We can't pop unless something's in our queue. So let's push first. So push was void. Push. Node star. And we'll take address, because that's what we're actually going to be sending it, the address of a node star. Makes sense, right? We got that. So we got a node star address, and we want to push this node, push a node into our queue that has this address. So again, looking back at our previous code, we want to see if there's anything we can use as a reference. And we remember that we do have this add node here in our pointer file, and this pointer file, that shows us how to add a node. Well, how does this one work? What does it do? It creates the node, and then where does it add it? How does it add the node? Where does it add it? As in the front of the queue of the list? It goes to the end, right? It checks to see if there's anything there. If there's nothing already there, it then navigates to the end of the queue and puts it at the back, or at the end of the list and puts it at the back. We did talk about yesterday with our mini challenge that we did with the whiteboards that we could do either way. We could push to the end or push to the front and pop from the opposite side. But again, it looks nice to have it pop to the front and push to the end. That's how we're going to work in the line anyway. In a line of people line up the back and then get pulled from the front, right? Line behind each other. So we're probably going to do that. And so does this do exactly what we want to do in our push function? There's a logic there doing the same thing? Yeah. There's a slight difference because if this one's storing an int, we want to store it in node star. But the logic is identical. So you can pretty much use this side by side and actually use it as a reference and almost completely cannibalize it with a couple changes. So let's do that. And in most of your editors, you can do a side-by-side coding system. Boop. Just like that. Now you have your code side by side, and you can reference your code while you type. This is a common layout for me. This is, again, why the whole couple lessons for the last 2 weeks have been about understanding your code. This is, if you ever look at any of my screens when I'm coding, I have 2 windows open at all times. I'm always referencing some other code as a way to just keep myself coding similar things, to make sure that I'm sticking to my standards that I've set for myself, that my code looks similar all the way through. I don't want some functions looking way different than other functions. So I almost always have a second item open where I'm using a way of referencing it. So first thing we did in this one is we created the new node and we gave it initial values. So let's do that here. However, what's the thing we need to change? What sort of node am I creating this time? Am I creating that? Right, Q node this time. Yeah, the Q node star, new Q node. We can do malloc. Size of what? Good. Yep, Q node. We don't want to use the original node because, again, we're only storing an address to that node, not the actual data of that node, so we only want the size of a Q node. That's you. Today's an allergy day today. So you got that. Now we want to... So we got our Q node down. Now we want to set the initial values. So the first one, of course, is new Q node. So it's not value. What do we call it again? What was it? What was the key we gave it? We didn't give it the key value. What was the key we gave? Not address. That's the parameter we're getting sent. And our struct, what was it? Go back up to the top and look at the struct. What was the key? Not next. It's node. Small case node. Right. The node star is being represented by the key small node. Because that's what it is. It's referencing a node. So equals, and that's where we put address, right? Small node is a node star. Address is a node star. There's your parallel. That's how you know that that's where that goes. Then over here, the last thing we did was we nullified next, just to make sure that it's nice and clear. This is beneficial for us in a couple ways, but one of the main ways is because it then helps to make sure that this new node is identified as the last item in our list. We use null as a way of knowing we're at the end of our list. So, what's that? Oh. Only one. And let me add my semicolons here again. All right. What does this code do again? Yeah, if I have no, yeah. Not that one. The next node, the if statement. Elaine, the if statement on line 34 on the pointer. Sorry. Oh, right, you're doing YouTube. Right, you couldn't get into Hangouts. Right, never mind. So, all good. Forget. Yeah, the if statement here is checking to see if we already have a queue, right? It's already saying, do we have a queue? If not, this first node we created is the beginning of our queue. That's what it's doing. Or in this case, it's doing it to the linked list. We want to do that here. So there's a couple changes, though, because root node is not part of our queue, is it? What is it this time? Head node. Yep, so head node is equal to null. It means we have an empty queue, and we need to actually give ourselves a queue. So head node is equal to new queue node. Again, I'm just copying what we have right here. So if I actually line these up, I can even do a little better. So if I do this, I can then scroll this to right there. Now this nice lineup of the code, so I can see what I'm doing. One more. There we go. I think that's close enough. Now in our add node, we did do a return, so probably should have the same thing. Because if you remember correctly, the reason why we did this was because as of line 202, we've completed our task, right? We've added the node to the queue. So we don't need to do any more, no matter what. Otherwise, what is line 39 for? On the pointer final.c file, line 39 does what? Yeah, it creates the traveler so we can travel our nodes. So we can get to the we can travel our list to get to the end and then add our new node to it. So we need to add it at the end of the list. So that tells us, since we already agreed that the logic for the pointer final for the add node is the same as we want for push, we can create a traveler. Again, we don't. What kind of travel do we want? Q node travel, right? So we want to travel through our linked list, not our binary tree. Q node star trav equals head node. And then pretty much the rest is pretty much the same, because now we use next. We don't use any other things. The only thing that's different is this guy right here, right? So let's do it. Let's copy this code. We'll paste it in and just change new node to new Q node. Look good? One last thing I'll do is we'll actually put in the function definition for pop. So pop does a node star pop. But in order to run the function, I do need to have something in the return. So here's a question. One thing we could do, nodes are a number, or pointers are a number, right? We've already talked about this before. They're a hexadecimal number, so I can just return an int if I want. So I can do return 0, and that would qualify the requirement that a non-null function returns something, right? If I want to, I can do this and have it return a hexadecimal form of 0, which is the same thing, just to make it a little clear that I am returning a pointer 0. So here's a quick question. Can I do that? Can I return the value null in a function that requires a certain data type? Unless you've done this, you won't actually know for sure. So again, yes. Not no. It's no. No is a thing. You think yes?
If you're saying return a data type.
So on this function, we're saying the function is saying I'm going to return a star. I'm trying to return null. Am I allowed to do that?
You're trying to return a star. Yeah.
Like that? So again, think about it. Again, there's no way, unless you've actually done this yourself, there's no way for you to know 100%. You have to answer it. You can take an educated guess. That's what you're doing. Working over the hypothesis, like you've done before. So, yes or no? Can we do this? Yes? Alright. We got 2 yeses. Anyone else want to think about? I want to think about it. Yes or no? Is this allowed? Is this valid? Say yes. Alright, everyone vote. Yes. I got yes. What did you say? I said yes. No. I said yes. Oh yes. You said no. No.
No, I think you said no. I said no.
No. What did you say? Yes. Lane, what's your guess?
I'm gonna guess yes just because everybody else.
You'll do what everyone else did, but you won't vote for no conformity. That's the line.
If you notice this, that's exactly what she did. She followed the group there too.
No, we can say that the node is
Recount.
not equal to none.
Good argument, yes. We are able to assign a node star to null, right? We can assign a node star to null. So it's a very good argument. That's how you can make an educated guess. Well, I can assign a node star to null, so can't I return a null as a node star? And that's really how you want to make an educated guess. Don't want a reason behind your educated guess. That's why it's an educated guess, not just a blind guess. In this case, I gave you a 50-50 chance, and there's a difference between a blind guess. So I'm just going to say yes for the hell of it, or I'm just going to say no for the hell of it. Think about your prior experience. What have you done before? What have we done before? And what makes you think you can do something or not? And that's an educated guess. That's a scientific guess and a hypothesis. There's reason behind your estimate. Based on that, they don't want to change their guess. Makes it any different? Yeah? Okay.
But can you scroll up just a tiny bit?
And where? Right here? Oh, yep.
Binary.
See a push. Yep.
Sorry.
When you do that, I'm going to get over to the spot I need to be.
Thank you.
All right, so there's our first get. There's our first good sign. We can make it without a crash. So the return null doesn't crash the program. Say, hey, you can't return null here. That's good. Probably. But of course, the best way to make sure is just then run the program. Make sure there's no runtime error. Looks good. Now we still don't know if our push doesn't generate a runtime error because what haven't we done with push yet? Right, we haven't actually used it yet. Before we do that, I do want to show one main thing that I was going to talk about before. I'm going to scroll back up to the top of my code, and I'm going to remove this Q node right here. I think I also removed the semicolon there as well. I did this in the morning class. How many errors did I just generate? I have 11 errors. What did I just remove from my code? I removed one word and a semicolon. This is what I've been talking about when I talk about the cascade effect of C in other languages as well, and what this can happen, especially in strict languages. In strictly coded languages, you can have what's called a cascade effect of errors. When you see an error, always work on the first one first, fix it, very top error, fix that error, then run it again. That one mistake there is causing 11 errors. I'm going to fix that one mistake by doing one quick thing, and it's going to fix all 11 errors. Done. So that's one of the main things you need to do in a lot of these functions, and as you keep going forward. And I've talked about it before. This is a good example. See it again. Cascade errors are a thing. You can have 12 errors generated by a single mistake. Always be aware of that. Because you see 12 errors, I'm like, oh no, I have all these errors. It's going to take me forever to fix them all. You may actually have one thing wrong in your code. Always go to the top item, the very first error, because again, a cascade error is caused by the first one at the top. There's the after. Fix that first one, run it again, see what else is left. Fix the next one. So the best way, if you want to eat an entire pizza, the best way is one slice at a time. Not trying to eat the whole thing in one giant bite. It would be interesting to see someone try to eat a whole pizza by never cutting it up. Wouldn't say that wouldn't be fascinating to see, but it wouldn't be the best way of going at it.
Yeah, I think Melissa gets segment.
So now we want to test this push function. Let's go ahead and use it. So we're going to make sure it's above for each tree. And I could do what the others did and actually add it to that function add node. I don't need to do that. I can just add the first item of my tree, right? That's an address. Root node is an address, isn't it? So I could just do push root node. Right there. As long as it's after populate tree, I can add the root node to my queue. We'll make it. Now any compiling errors there could have happened. This will give me any runtime errors. Good, no runtime errors. But to know for sure, I can now use valgrind. And see that I should have one block available. One block is 16. And again, the way I can confirm, is this a Q node block? I can take, since I know this is a 16 block here, I'm going to go ahead and take 16 out of this. So 304 minus 16 would be 288. If I then divide that by, it looks like 12 frees. So that means there was 12 nodes added to my list. Oop, I forgot. I need parentheses. 24 bytes per node. So a node is 24 bytes large, while a Q node is 12 bytes. Oh, sorry, 16 bytes, right? Yeah. That's how we know it's different. That's again how I can prove to someone who says, well, how do I know this push function definitely works in adding the correct node? So,
Because two addresses and one income. So 444.
addresses are not necessarily 4 bytes. They are defined by the operating system being used because the length of that item needs to match whatever the memory of serial.
So it's now for 64 bits.
Yeah, it's 8 bytes per int, 8 bytes for 8, 16, 24. So you get 8 bytes for each item. Cool. So. Here's 8 bytes per int. Here's the block. The block. There you go. 888 is 24. 888 is 16. Cool. And then the last thing is that, again, to prove it's in the still reachable, which tells me that I not only created the queue node, I added it to the actual list. I linked it to the root node. But let's go ahead and double check even more by adding a couple more things to the root node, to the queue. Now, I could add the root node multiple times, but that just seems a little dumb. So I'm going to do push root node low and push root node high. Those are both node stars, right? Root node low and root node high are both node stars, so those are both item addresses I can add to my queue as well. And that would add the first 3 items on my tree to my queue. We'll run it, make sure there's no runtime errors. Yep, wrong one. That one. And then we'll val grind it to make sure I have 3 in the reachable. 3 still reachable. Woo. Sorry. The console or where? And where? Right here? Okay. Cool. I'll give you a second. Take a look at this. Look up. And then you don't have to code alongside me this time, because again, this video is going to be up on YouTube. You can go along with that later if you want. So. We are running low on time. I want to finish up a couple more things. We do have a challenge for the next 2 days.
We should be still reachable 48.
Yep, 3 blocks. Well, if you don't have the binary tree node inside of it, add this over. Add this on the bytes. I'm not actually storing the node inside of it. That's my reference, not that out. Yes, population tree is
That's your free.
yeah.
Your
That's why the people only have the free node. They go all the way down. That's yep. That'll work now. As far as
I'm getting different numbers.
I don't know. He's getting to a.
what's that?
He's getting 288.
I don't know if
He's
she's
getting
what.
it at 288.
288 sounds binary.
Yeah. No, it isn't.
It means that you don't have free tree running.
You don't have free list.
Free tree is what kills those out. First one. Don't be this. First error. Okay. That. Cascade errors. Yep. These 5 errors with 1 semicolon.
Yeah.
There you go. Cool. Anybody else have a problem? All good, all good.
So if I have a problem, me and Dan do.
Touch your break.
Let's see. So I was following along, but when I link it, it says
The first one.
you have to declare the top on top. I did. I just deleted that. I tried to roll it. So I.
You do want the declaration there. And then you have that small bit. Push doesn't actually return them. Sorry.
Where?
It's returning as a pull.
There? Where on your chest?
That error means if you tried to use it before with declare.
Yeah.
I'm like so.
Cool. All right, let's keep going. Now I want to create pop. Remember correctly, in our queue, so if you remember correctly from yesterday's exercise, those were here. Pop comes from what part of our queue again? Where do we pop off from? The head, right? The beginning of it. When we reassign our root node. We pop off the head, and we grow a new one, or at least reassign the head to some other part. So on a new head or something. I don't know. We don't put the original head back. We say, okay, that head's gone, we have a new head now. Sound good? That's what we want to do in this function. We want to remove that head. Not only remove it from the queue, we also want to return back the address that that node is storing. Right? So we did say that there was a function we can use as a reference as well. We can use the remove, but not really. This item actually goes through and goes to the end of our list, right? So remove node isn't really going to help us this time. We could look at it if we get stuck in something, so we can definitely have it open. We're definitely going to try to create this from scratch, but look at this if we need any guidance.
Can you look at the link list for that?
Yeah. Give it a second. It's going to load.
Oh, is that what you're doing now?
Yeah. Give it a second. You'll see that I have remove node open on pointer final.c in a second. There it goes. Yep. The delay. So now we're actually going to work on node star. We don't need this return null anymore. We can go ahead and rid of that. So what's our pseudocode here that we talked about? So the first thing is we want to reassign the root node, head node, right? We'll do that. We also technically want to the big thing here is that we want to get, what's the purpose of pop though? Right, we want to get the value of the nodes. We want to return the address of a binode, or binary tree node. So by dash node, I'll say. And we want to reassign the head node. Looking at this pseudocode, there's something a little off. What's the first line doing? What's that word in there? Return. Right. And in the code, if you do a return, you can't do anything below, right? So let's swap those quick. Cool little shortcut is you're on a line, you hold down the Alt key, and use the arrows. Oh, I don't think that works in this one. Dang it. Yep, nope, doesn't work in C9. Never mind. In Visual Studio Code, holding down the Alt key, you can actually move a line up and down through the code. Yep. So I could actually just use the Alt key and press the down arrow, and this would actually move down one row. So yeah, we want to move the reassign and then return. But now again, we have a thing here. So reassign the address of a binode. Let's make this more specific. Which binode? The head node, right? You did? Oh, weird. No, my mind didn't. I'll figure it out later. So you have to return the address of head node. But now again, we have another problem now. Don't we? We have another problem. Look at that. Look at that pseudocode. You do want to reassign the root node, the head node, and then we want to return the value of the head node. Well, we just reassigned it, right? We reassigned it before return. So based on the pseudocode, what do we need? Yes. We need a temp to store that head node before we reassign. Let's add another line of pseudocode. Temp store the head node. So let's start there.
And then when you reassign them,
Right, we'll get to that point next. So, then again, pseudocode. We don't need the specifics. Yeah. So let's do the first thing. We need to do a temp store of our head node. So what data type am I doing? All right. Q node temp star temp. Yeah. Equals head node, right? Cool. So we now store head node. So we're not traveling. We're staying at the front, aren't we? It's just it's storing the temporary. But that was it. Travs weren't temporary variables. Travs were a traveler type. They traveled through our list. They weren't a temp store. Always remember the meaning of the variable does have a meaning. The name of the variable does have a meaning when we create them. They should mean something. So this one is just going to hang on to that item. It's not going to change in any way, shape, or form. So you have a temp holding on to head node. So now we can reassign head node safely, right? So now we can do head node is equal to what? We could do temp arrow next too. We could also use head node next, but either one, both work. So we can do that, temp next. So now head node has moved on.
Anyone else?
We can also just use head node again. Just like we do trav equals trav next. We can do head node equals head node next. But we can also use trav because we can use temp as well because they both point to the same item right now. So either one works, whatever one makes more sense to you. And then our last line says return the address of head node, which is now what? Temp. So let's do return temp what? Not value. What did we start? What was the key we used? Node, right? Small node? Temp small node. Remember, temp is a Q node star, and we want a node star back. So we return temp arrow node. So one thing we could do here, another way to write it, is I could do this. And I actually kind of like this one. Head node next. And instead of storing the Q node temp, I don't need the address of the node, do I? What do I need? I just need the address of the item I'm returning. So I can just do node star temp equals head node node. I could do this as well and then just return temp, right? So that's another way to do it. So an alternative way of doing it, I can instead have temp store the value I want, reassign head node, and return head node, and return temp, right? That's another way to do it. Well, we'll go back to the way you guys came up with for now. I just want to make sure I show two different variations of the same item. Either one, in both situations, we still have to navigate to node anyway. So neither one really makes a benefit, it makes a difference in this case. All right, so let's run this. Let's see what we get. Do I get any errors? Let's see. First, we're going to check for errors. Nothing there. But again, we haven't called it yet, so we're not going to run it. Nothing's changed. So let's go here and now let's run it. How can I run it? How can I test if it works? Because if I pop, I'm going to get an address, right? So how can I test this? What's that? Well, I get back to add a node. What's inside of a node? Value, which is a... What is it? So can't I just print that?
I was trying to print out the other one.
I can print out the value of the node that was returned to me. Let's do that. We can now do printf %i/n pop. But now you're probably thinking like, well, we should probably store that in a variable because I can't really access value, right? Well, pop returns a node. Could I do this? Looks weird, right? Can I do that? Just believe me. Right. And we've already understood how do functions work. How do functions work? When you see a function call, what happens to that function? It pauses, right? That function pauses. It won't evaluate the line until the function finishes calling. And the function promises it will return a node star, right? It says, I am going to return a node star. This does have the chance to error. Why? A node star could be null, right? And null value is a second case call. So this does have the chance to crash, but not necessarily. If we do get an address, now we're doing an arrow on a pointer, which is valid.
So you'll return the address and the value.
The address will have a value. So just like in JavaScript, we can dot chain. Remember how we used to do that in JavaScript? We can chain on from this with functions as well. Because again, that's why strict items make a difference. We are telling the code, this is going to return a node star. And so we can treat pop as a node star. Kind of cool, right? I hope so. I found it cool when I first found out about it. So let's check it. Let's see if it actually works. Let's make sure. Don't just take my word for it. There's our 10. Let's do it again. Let's make sure we actually are going to, when we also reassign, we get the next one after it. So let's copy this line, print it again. We'll save it. We'll run it. Make it first, then run. 10 and 8. Nice. Well, let's val grind. Let's see what happens when we val grind. Yeah, that's interesting. I get 1 still available and 1 definitely lost, 1 indirectly lost. That's an interesting result, huh? Mini exercise. I need whiteboards. Yeah. I don't know if I have enough erasers for everybody, so you might have to share. We'll find out. I want to give my guy lashes.
That was there before we started.
It was?
Yeah.
I didn't notice that. Oh, thank you.
I think that happens when you get rates of environment.
That might have.
You like hold it on?
Oh, sorry. Separation.
I didn't actually count them out, so you might have extra.
We do.
What's that? I did not count.
More out.
Try not to get you.
No markers.
What? I did.
Good. Everyone has an eraser and marker and a whiteboard?
No.
So, here's your mini challenge. After push. Hello, CareerDevs. Alright, so, after. Side.
Just drawing a picture.
Is there a blind side of this?
Yeah, I'm gonna use the black side. The eraser. You're making my poor smiley face dirty. You're not the first to do it, you won't be the last. If you take a look at most of our races, I swear half of them have dark and have like a dirt face because anyway, so as a push, at the end of push, our queue looked like this. We have 10 connected to 8. We push 8 next, and we connected to 15. Our root node, or head node in this case, points to 10. Your goal is to walk through the code of our pop function and figure out what happened here. So walk through the code of pop and figure out why we're getting what we got. Alright? This again is going to help you understand how to understand your code and how to walk through code using whiteboard. So this is our cue as at the end of push. We run pop twice. So run pop twice on your visual whiteboard.
Oh, I know.
And see what happens. Keep it simple. Right through it and show me what the end state is, and then you can explain it. This is your cue at the end of push, right? After the 3 pushes, we push our root node, which is 10, our low node, which is 8, and our high node, which is 15. So based on how this works, using visual aids, walk through the code of pop twice and see what happened visually. Move the arrows around, create and remove variables, whatever you need to do to understand what's happening here. Why are we getting that weird val grind? So, you have, and yet,
There.
and then call me over when you think you've seen, two things, again. What do you think the state of our queue is at the end of the 2 pops? And what do you think why we're getting the val grind we got?
pop doesn't remove it, does it? Yeah, follow each one of the code. You will use one by one, what each one of the code do. Where in which line actually removes 10 from the list? Probably seen the problem there, I mentioned that. It is. You're gonna have a long thing.
That's the trick.
Initial point.
Hold on. Pop. Do you want to run that code down here? Pop.
Do we lose the initial pointer to the
Possibly. What do you think? How many codes?
So just
That's one
at the
problem,
beginning head node was facing 10, but now it's facing 8, and you know 10 is
That's
still
only one
facing
problem,
8. Yeah, it's only one node.
That's the one.
Second row. So then
You want to
head node
include
is
both
facing
values,
here.
right?
Yeah, I saw we had 16 bits on this, so these were all still two.
Definitely lost and an indirectly lost. An indirect, a directly lost, an indirectly lost, and a still reachable. Definitely lost.
Let's say someone is doing
Indirectly. That's the idea. Again, I will never tell them if they're right or wrong until the end. I'm going to be hearing me like, I got it now. You got it? That's true. We can do this. So which ones are technically facing? Indirectly? Like it. See if you're right in the end. I don't say yes or no yet. I like it. Yeah, mark the line. So, line 2.5 is what? Temporary one, right? Write the word temp. That's what head node is, right? Head node is variables. So you just create a variable just writing the word. It's a variable. Well, no, head node still exists. You didn't get rid of head node. Head node's a variable, right? Pointing at node. So that's what temp is, right? So just write the word temp somewhere. Then write it right next to it. And just squeeze it into much. And point it to whatever temp is being assigned to. So we create the variable temp. What's temp pointing to? Which is? No, what's head node pointing at? So what would temp point at? Temp would technically point at 10, right? And then what does the next one do? 26. What does that do?
The next one.
There. 10. Code again. Take a look at the code. What does actually happen? Which one is it? Isn't the one on the left-hand side of the
Oh, yeah, ramen like a monk.
Oh, head node.
Yeah.
left side gets reassigned.
So,
Change head node.
So head node is 8.
So here we go. And hold on. The next line returns temp, which technically kills temp, right? Temp is scope. Return that outside the function. Because temp is created inside the class. Temp no longer exists until the class finishes, right?
someone I
Yeah, but I don't understand.
That's one iteration of pop, right?
Oh,
This is how you walk through the code and do one line at a time.
because then the temp is going to point to 8 and then it's already going to point
Then now you have to decide which out of those three nodes, which one's the definitely lost, which still reachable, and the indirect lost. Oh, worry. Never lose that one.
but that was the key.
And it has
I should have lost it. That line is reversed. That's what you don't really do anything about that. You never change this line, do you? This one does. Head note doesn't. So now which one is the other one, the indirect loss is? Indirect loss is still something technical, right? So, which one is indirect?
You know who he is, right? Cute.
What?
Didn't work.
You got it already?
It's confirmed.
Yeah, I had it the first time, I just didn't have the logic. Yeah. No, I can figure it, like my assumption is,
Yeah.
yeah. Right.
And then your head router actually gives you a sign, right? Doesn't have to change it to 10, you know, 8 doesn't. And this thing is the second one exists with your turn, right? So that is really the the second time, temp then will go to the new temp, and it's an 8 will be right. You sign it again.
You've probably been at the house when I
Right, and I'm looking at these, which one is direct, but you could also.
I just started hanging out.
And you kind of choose which one you want.
I've heard them mention
How we doing? Over here, what do we got? What do you have? What's the first?
so
Alright, we'll let you go that.
this is a teardown.
Alright. First pop.
I think it's.
First pop, and
I
that's
think that's
well,
important to drive you.
Yes. I'm gonna get that one.
Yeah.
That's how they are actually, something's still connected to it.
Yeah, that's how whoever was trying yesterday, trying to.
We didn't say sure yet. Let's finish it with the second pop. What happens in the second
there's a
pop?
link to it that has a point.
Well, in the second pop, what happens? No, we run up twice before we get our message.
It's going.
I'll definitely make a note of that. Head node is not going to get confused then.
Yeah, I do mine circle, but I split them just like that.
Otherwise, stop thinking about it.
Right, yeah.
Yep.
So
Oh,
it's
right, the newest one.
whole piece of
So
pie.
again, so we had the bird. So those who were here yesterday, we saw we had the bird. Don't forget to tweet. There's Art. I think Jackie claimed it last time. Don't forget to tweet.
So even
So I'm having fun with these now too. So now I have surprise people, but at least this one actually has a meaning behind it.
You constructing meanings behind things.
Not true. Still fun.
It's more fun if it doesn't.
Anyway.
Less angry.
So now think about which one's directly, which one's indirectly.
this is indirectly.
Maybe we'll explain why in a second. Come back. What do we got? Very good. We've got it. So again, this is kind of how. So again, the whole point of this was just to really get an idea of how do you navigate through your lines of code to understand pattern. As you can see, we've done a pattern for the last 2 weeks, and that's what I tend to do. There's a certain topic we try and drill home in certain lectures. In this lecture, called understanding what's happening in code. Understanding your code, so you can use it, explain it, and discuss it. In this case, what happened is we ran pop the first time. So you literally just write on your board what's actually happening. The very first line of pop creates a temp variable.
What
Temp.
are you trying to use for that?
Temp is the same variable as kind of head node in our version. We did a Q-node star. Head node is Q-node star, so we can make it look the same, just the word. And then it points to a pointer. And you put the head node, well, head node points to 10, so that points to 10 too.
Turns into heads,
We then reassign head node. Remember, in the next line, whatever's on the left-hand side is the item that has changed. The left of the equal sign with its modifier. The head node becomes head node next, or temp next. Temp then gets returned. But we only care about the pop function, what's happening to our queue. So we don't get returned, we don't care that it's returned, and we know that since temp was created in the function, as soon as the function ends, anything created within a function is lost. So this variable goes away. That's what physically happens in our code, right? We do send it back to our system, we can keep track as we want, but because we're only caring about what's happening in our queue, we don't really need to keep track of where that 10 went.
So that's indefinitely lost.
Not necessarily. Not yet. Hold on. We want to make sure we get all our code done first before we start making assumptions yet. Because something else could change. You might be on the right path, you might be able to make a decision now, but it's always good to go through the whole process before you start making your deductions sometimes. Can you make can you estimate in the beginning? Of course. You can make an estimation. I think I might have found the thing that was indirectly lost or definitely lost now. So you always want to save your final decision until you finish with the whole process. Now we run pop again. You then create another temp. This time temp gets pointed to 8. Head node gets reassigned to head node next, which then assigns it to 15. Temp gets lost, or gets returned. So temp goes away, nothing exists. We still have 3 nodes. So we already know one thing we didn't do as part of our pop function, which was we didn't free our nodes. So we have our leaks. Now we need to figure out, so our Valgrind is telling us one node is definitely lost and one node is indirectly lost. So out of these, which one is the definitely lost? So we've got a pretty good idea of 10. Why is 10 definitely lost?
Because of it.
Like what is, there's nothing pointing to it that has definition.
There we go, yes. There's no identifier that has a pointer. There's nothing connected to it. We can't get to it in any way, shape, or form. We can't reference it. Why is 8 indirectly lost? Well, not 15. Not that.
It's from 10. 10's point.
Right. 8 is pointing. 8 does have a reference, but it's referenced by a lost item. So because the item connected to it is lost, it is also lost. We can only get to 8 from a lost item. So because of that connection, we can't get to 8. Why does it make that difference for us? Why does Valgrind tell us that difference? Any guesses? They're both the same level of lost, right? If you really think about it, they're both lost in our memory. They both leave.
So you can figure out where the error is?
Exactly. It's Valgrind trying to help us understand what's going on in our code, and so we can figure out where the problem resides. It's for us to better understand the situation. 8 and 10 are still connected, so there was no partial item lost, only free. There was nothing in between the two that was free, so that both 8 and 10 were directly lost. If we had something that was partially freeing stuff, like sometimes it freed things and sometimes it didn't, we would see this kind of breakup of something directly lost, something definitely lost, or everything directly lost. Or sorry, definitely lost. So that's the idea of Valgrind. Valgrind is giving us this little more detailed information so we can make better gauges on what's happening in our code and find the error and find the problem earlier and figure out where our free is not happening. Where are we not freeing code? That's why. Both items are just identically lost. There's no difference between the two. I lost 16 bytes, I lost 16 bytes. There's no arguing that. But by giving us that information, we can know that, well, we have one node that is indirectly connected to a lost node. Oh, that probably means it's this guy. So I look at my code here. So I need to start freeing these. So let's do that.
Let's free our nodes. It's the last thing we're going to do today. Then we have everything we need. So now we got to think about it. How do we free this? So I need a free head node, but I reassign head node. So I need a free temp, right?
Free head node before you move.
What am I doing?
Free head node before you define new head node. Well, it's still defined by temp, so in between Q node.
This thing here?
Head node.
Ah,
Yeah, why can't you just do that?
very good. Yeah, that actually worked. Why did I not think of that this morning?
Power of God.
No kidding. Another way you could do it, to just make it a little easier, is why I showed that you could do the node star. Because you could also create another temp. But I actually don't want to go into that because this actually is much better. I like this. So, because we are reassigning head node, we can actually free head node because we already saved a reference to. Wait, can we do that actually? Hold on.
Because we're referencing it again.
We are referencing node temp node, And if we free the item at that address, temp is now pointing at a freed item. So no, this will not work actually. Yeah, I think. I was gonna say, because once you free head node, since temp is pointing to the same address head node is, temp becomes null. I like the first second. It looked good, then I realized no, there's a problem. It does? Are you sure? Yeah, I'm gonna run it. Yeah, I'm running it. I will run it. I will confirm. See if it works. Nope, I got segmentation faults. Shouldn't work. There is, I guess, a possibility that the data may still exist for some of you because of caching and stuff. So it could possibly work because the data is still there in a way, but we're freeing that stuff from the system. So it's not a safe way to do it. Because we're going to the address of head node and we're freeing it, and what temp is storing is head node. Remember that. It's storing the address of that spot, and then we free what's there. So that's dangerous to do. So what we really should do, actually, is what I was going to do before. Nope. Let's do this. Ready for this? We're going to actually do node star temp, head node, node. So our temp stores the item we want, the actual address that we want. That way we pull the address out of the node entirely. That address of the node we want is now completely independent of the node it was in. We no longer care about the queue node. That means that that queue node is now completely free to be removed. We can't free it because then this won't work. This now doesn't work because this now isn't actually a queue node. So the thing is, we still need another temp. We need a queue temp. Once we do that, we can then, let's do the reassign first. Nope, not queue node, queue temp. And then we can free queue temp. And then, oh, right here on this line as well, we just return temp. Nope. What? Oh, yep. Thank you. Thought I hit the shift key. So what we're doing here, line 225 extracts the item we want from the node. That means that that address we're looking for is now safe on its own, independent, no longer attached to the node. So when we free that node, we don't lose the connection to that address. We then get a temp, so we can then reassign the head node, but still attach, but still reference 10. So when 10 becomes 8, we can still reference 10 with our queue temp. And then free queue temp. Again, just see it on our whiteboard again. Originally what we were doing is temp was pulling out the whole node, the whole 10 node. But not the address of 10, not the binary one. It was still pulling out the one with a single arrow. Right? It was pulling out that one. What we're changing now is temp is going to pull out the address of the binary node, the two branches, this version of temp. Now we're getting that version instead. That's what temp is now holding. Originally we're holding the Q node version. Now we're storing the binary node address. Additional point of 10. If we freed 10 now, we would be able to reassign head to 8. Right? So we need to do the reassign. But if I reassign it, that's my problem. I can't free 10 now because I have nothing connected to 10 anymore. Remember, this 10 is the binary node. I need access to the Q node 10. That's why we need our Q temp. So Q temp is then created. And Q node gets a reference to the 10 Q version. See? It has a single pointer to it from it. That's the binary list of it. Not binary. That's our linked list variant. Now we can reassign head to 8. So yet we still have a connection 10 from Q temp. So we can free Q temp, which then removes 10 from our number.
See why the whiteboard can help us understand what's going on? Because this part is a little confusing.
You're free, oh, you're free Q temp.
And that's what
That's in the,
allows us to do.
that's in the queue.
Yep.
So when you free it in the queue, you already, you have it.
Having the temp, now return temp. Temp stores the binary. It's like return temp. You can get the binary like the binary tree out. You extract it from it. See like the two legs? So the
Yeah,
one-
wait, I'm wondering why. You go in and you look at 10, you extract the binary 10. Oh, because it's already in the queue. So you're in the queue, but you're extracting the binary.
reference to the binary. So anyway, that's what these guys hold. This doesn't store the number 8, it stores a reference to the binary 10 8. So that's what I extract here. I extract that binary 10 from my queue here.
So temp is going to give you the value,
It gives us the exact node star that we
and
want.
then you're just managing that queue.
After that, yeah. As soon as I extract the data I want, now I can freely modify the queue without worrying about it. I already got the data I want. Theoretically, if I really wanted to, that very first line, I can make that first line return state. I'll have a homework memory leaks, and my system won't actually move to the next item in the queue. But that very first line, I now have the data that I want that pop is supposed to return right away, right from the beginning. So once I have that, I am free to mess with my queue all I need to. Whatever I need to do with it, without having to worry about whether or not I have the data to return. Sound good?
All right, your challenge for the week is to start implementing display level. Here we go. Display level. Think of our pseudocode. Yep. We have our tree here. We want to start at our root node, right? Start at root. Start at root. What was the very first thing we do? The display level. What's the instruction that I'm saying we do? Split. And display first. Could. Not make a big deal, but what I usually do. What's that? That's why I added my queue, don't I? I add the children to the queue, don't I? Right. The very first thing I do when I get to that node is I add any children to the queue. All nodes. Right? Then what do I do? I want to print the node I'm on, right? I don't want to print 10. I don't say to print the node I'm on, right? Once I added the queue to the node, once I added the children node to the queue, I can now print the node I'm on.
So you add low and high, both the two. First row and then.
That's the way we're going, yeah. We want to go left to right. So it's low then high. We print the value of the node I'm on, and then what do we do? What's that? We release that node, then we do what? We do what with our queue? I get the next item from the queue. So yeah, I'll say get. Get next item in queue. And I get the next item in the queue. What do I want to do with that? There's our looking for. Do I need recursion here? We do. I don't need to go back to any of the previous nodes, do I? I don't need to go back up the chain, do I? I don't need to set up a domino system, do I? No recursion, you can use while loops. Start at root. I've already read the comments as well, right? I've already read the comment in the code. So, I'm going to put in a comment. I'm going to create the function name and put the comment in. So, this is what you guys are going to create. This is your pseudocode. So, right here, using this line, what can we use for this? What function do we use? We use to push. We use push, right? Don't do the full code. Just tell me what function we use. Not with the if statement. Yeah, we can push. And what function do we use here? Pop, right? And let me clarify something for you. You will not get the actual pure item that you want. That's not what you're going for. Your MVP today is to print one line in the correct order, though. You want to see the order that they enter the node. So in this case, Well, actually, the one we have, but in this one, this is going to look here. We want to see the items 10, 8, 15, 5, 9, 13, 20, 4, 7, 17, 6 on a single line. Because there's one thing we haven't discussed. How can you know to hit a new level?
Yeah, that's what I was wondering too.
We don't know that yet. That's what we're going to. That's the final item we can figure out how to do on Thursday. So your goal today is to at least, at minimum, just get this all printed out in a single line, but in the right order. Where you can say, well, that's where the comma go, that's where the new line would go, that's where the new line would go. I know where they would go, and it is printing correctly. All you do is get the print in the line. So you have to discuss how we figure out how to get a new level. How do we know we've gone down a level? That's what we'll discuss on Thursday. This is your pseudocode. You have the 2 functions you need. Now you just got to commit the logic, and on Thursday we'll figure out the final piece of this item. We're done with C. I'm good?
We're good.
I'll write down the code, and I will share this version of
Pointer of binary tree.
Thank you, Lois Cliff.
The cliff?
Donde está?
No, 15 seconds.
No,